Hello guys, welcome on Tesla Adventures. In this video today, we are going to discuss the PN junction diode as an rectifier. Have you ever imagined that your mobile battery is a DC battery and you are charging it through AC, which is provided in your sockets of your home electricity? So this conversion of AC into DC is done by your charger, and there are two major functions of your charger. The one is the step down function, because your household is in India. Obviously in US it is 110 volt AC, and in India it is 220 AC, which is provided in the sockets of electricity in household. And your mobile battery is merely working on 9 volt or 12 volt DC. So the transformer which is inside your charger is converting that 220 volt AC into 9 volt or 12 volt DC, and the rectifier inside your charger is doing the conversion of AC into DC. So rectifier is a device that converts AC into DC, and rectification is a process of conversion of AC into DC. So let us first of all discuss the half wave rectifier in this video. So you can see that this is a arrangement in which there is a transformer coil which are mutually coupled. This is primary, this is secondary, and the primary coil is connected with the oscillator, which is AC battery, and the secondary coil is connected with a diode and a load resistance. Now load resistance is a high resistance that converts the current into voltage. So you can see that this is the input signal, and let us write down the input signal Vi as V0 sine omega t, and this is the t by 2, this is t, this is 3t by 2, and this is 2t. Okay, so let us suppose that when positive cycle is occurring, then this is the positive terminal and this is the negative terminal, and hence this will be the negative terminal, this will be the positive terminal. And due to a phase change of 180 degree in mutual induction, this polarity will be plus and this polarity will be minus, and this is the P side of the diode and this is the N side of the diode. So this diode will be in forward biasing, and in forward biasing it would offer a very little resistance in the circuit, and it will allow almost all the current to flow through the circuit like that. And when this current will flow through the load resistance from up direction to down direction, then this terminal A will be positive and this will be negative. So a positive half cycle will occur because we are considering VA minus VB as output. So VA will be positive and VB will be negative. So VA minus VB will be positive. So this positive half cycle will be occurring, and let us suppose that this is the peak value of the output voltage Vm. And now when the negative cycle will occur, then the polarity will change. It would be plus on the above side and this is minus. So this will be plus and this will be minus, and this polarity will be minus and this will be plus. So this diode will be in reverse biasing in this case. So it would not allow any current to flow and current will be zero. So this cycle will be empty in the output, and there will be no output received in this cycle in the period of t by 2 to capital T. This is T by 2, this is capital T. Then again positive half cycle will occur, then again diode will be in forward bias, then again output will be received. So you can see that the output signal is received only for a half cycle in a complete cycle. So this is called as half wave rectifier. And you can see that after T time this input signal is repeating itself, and after T time this output signal is repeating itself. Okay, so we can say that frequency of input signal and frequency of output signal will be equal, and the time period of input signal and time period of output signal will be equal in half wave rectifier. Now let us talk about the output average. So let us write it, let us calculate in the terms of voltage. So let us see that this is V output, and the maximum value of output voltage is Vm. So first of all, let us talk about Vm. So we know that the output signal is received, V output will be Vm sine omega t in only half cycle, and it would be 0 in the second half of the cycle. So we can say that this will be like that, and the average value of output, V average, will be integration of Vm sine omega t dt. Limit will be from 0 to t by 2 divided by the period, which is t by 2. So this will be 2 Vm by t, and integration of sine will be minus cos omega t by omega, and limit will be from 0 to t by 2. So by calculating this, you would be getting V average as 2 Vm by pi, and Vm is the peak value of the output voltage. So we can say that this is the average value of output, and this is VDC also. So if we talk about the value of IDC, then IDC will be the current flowing in the output circuit. So IDC will be equal to Vm, where Vm is the peak value of the voltage across the load. So IDC will be equal to, see, you should always remember that IDC is the current flowing in the output circuit, in this circuit, and in forward biasing, this voltage developed across this secondary coil is exactly equal to Vi in magnitude. So the current flowing in this circuit I, secondary circuit, will be calculated by I output will be calculated by V0, where V0 is the peak value of the input voltage. So we can say that output will be V0 by total resistance of the output circuit, which is load resistance plus resistance of diode. This is diode resistance, and this will be sine omega t. So this is the peak value of output voltage. Okay, so this is I output peak value, and this is V0 by RL plus R. So the this V0 is the output voltage, and we can say that Vm is the peak value of the output voltage which is received. So Vm will be equal to I0 into load resistance RL. So it is V0 RL upon RL plus R. This is Vm, and V average will be therefore equal to 2 by pi. This is VDC, 2 by pi into Vm. Vm is V0 RL by RL plus R. So this will be the DC voltage or output voltage received in the. See, it is very important to note that we are converting the voltage across load as output voltage. So we are considering V output as this one, and I0 is the output current, will be the current flowing in this complete circuit. Okay, so this is very important to know. Now if we talk about the performance of half wave rectifier, then it is measured by two factors. One is ripple factor and the second one is efficiency. You do not need to dig deep in these two factors because these are out of the syllabus, but If any question is seen in the paper that what is the ripple factor, so you just need to remember the value of ripple factor for half wave rectifier, that it is 1.21 for half wave, and ripple factor is the RMS value of AC of input signal, and it is the divided by the average or DC value of output signal. This is ripple factor. And efficiency of half wave rectifier is the DC power delivered to the load upon AC input power from the transformer. This is the efficiency, and for half wave rectifier efficiency is 40.6%. So you just need to remember these two datas. So in next video we will be discussing the full wave rectifier. Thank you.